Chapter 3 is on linear equations in two variables, and the first section is on graphing linear equations in two variables. So our first objective is to talk about the rectangular coordinate system, and this grid down here, when we fill it in, is going to describe some of the pieces of that rectangular coordinate system. So the rectangular coordinate system is a set of two number lines that cross. We're going to call this first number line the x-axis. X is the primary variable we use to solve most equations, so it's our standard axis. And if we already use x, we're going to call this one the y-axis. And the first piece of information that's important here is to notice where they cross. And the x and y-axis cross is at 0, 0, or at the origin. They cross at the origin, the place where the grid's is beginning here. And then I also want to think about the fact that I'm going to count upwards in a positive direction along this number line, or this x-axis, and negative numbers are going to be going backwards or to the left. And then it also makes sense for the y-axis to count upwards in the positive direction, and downwards then would be the negative direction. Okay, so you could number them further, but it just gives us an idea what's going on right here. So this grid is just two number lines crossing. I can count upwards or over, down or back. And it separates the grid right here. The rectangular coordinate system separates the grid into four different pieces called quadrants. This one right here is the first quadrant up in the upper right-hand corner, the first quadrant. Oops, my bad. Let me erase it real fast. Quadrant. There we go. And it makes sense that this one is the first quadrant because this is the quadrant where the x values and y values will both be positive. So that's our initial or home quadrant, the first quadrant. We just number the rest of them around in a circle. So we have quadrant 2 over here. Let's just go down. I'm not going to write the whole word quadrant. Let's put a Q for quadrant, quadrant 3, and finally quadrant 4. Using Roman numerals right here is typical for quadrants 1 through 4. Together, this whole thing is the rectangular coordinate system. It's called rectangular because, again, these axis lines separate this grid into rectangular shapes. We're going to use this rectangular coordinate system to graph our linear equations. The next page we have a blank is a pair of numbers. That would be an ordered pair. There we go, an ordered pair. It's a pair of numbers in the form x comma y, where the first number is called the x-coordinate, and that denotes the horizontal distance and direction from the origin. The second number, called the y-coordinate, denotes subsequent distance and direction from the x-coordinate. I should make a note, this is the subsequent vertical distance and direction. Y is vertical where x is horizontal. So let's take a look at what we're talking about here. I want to plot some of these ordered pairs. Let me plot pair A in red here. So it is 2, 8. These ordered pairs are always in order, like ordered pairs indicates. They're always in order. So I'm always going to be told the x value first, then the y value. So along the x-axis, I would go over 2. From there, I would go up 8. And this would be the location of that point A. Okay. In the next one, part B, 8, 2. Always starting from the center, I would go over 8. From that 8, I would go up a distance of 2. So this would be the ordered pair for B. C, 4 and negative 2. 4 is the x direction. Negative 2 is the y direction. So instead of going up 2, I'm going down 2. In D, the x direction is negative, so I'll go backwards 1. Y direction is 3, so then up 3. Let me scroll down. In E, the x direction is negative 5. The y direction is negative 2. So put it over here. In F, the x direction is 0, so it'll stay right in the center, and then it will go up 7. And for g, the x direction is 4, the y direction is 0, so it'll go over 4, and then it will stay right here. It won't go up or down at all. And lastly, h, the x direction is -1, the y direction is down 2.5. So not quite down to 3, just 2.5. We'll put it in the middle right here. That's going to be h. Okay, so we can graph an ordered pair by graphing the x and the y. Note we use the phrase ordered pair because it does matter, the order matters. We note that 2, 1, for example, is not the same thing as 1, 2. 2, 1, just for contrast right here, 2, 1 would be right there. That would be over on x2 up 1, whereas 1, 2 would be over 1 then up 2. They are not the same ordered pair. Let's go to the next page. In the second objective, we're going to label the coordinates of these ordered pairs. So A is the ordered pair that from the origin would have been 5 over, then 3 up. Always list the x coordinate first, the horizontal coordinate first. 5 over, 3 up, so ordered pair 5, 3. For part B, from the center it's -6, 5, -6, +5. And C, from the origin, it's back 2, -2, and down 2. So -2, -2. In the next objective, we want to determine whether an ordered pair is a solution to an equation. This is very similar to determining whether a number is a solution to an equation. This ordered pair is telling us that the x value is 2 that we're considering, and the y value is -2. So I'm going to plug both of those values into this equation and decide if it's true or false. So if it is a solution or is not a solution. So the x value is 2. So we've got 5 times 2 minus 2 times the y value is -2. And we're going to find out what that's equal to. And we want to know, is it equal to 6? So 5 times 2 is 10. -2 times -2 is +4. So in this case, we're coming out with something that's not true. So the answer in this one would be no. That ordered pair is not a solution. Okay, let's look at the next one. The x value in this ordered pair, the first value is always the x, alphabetical order, right? X then y. It's always x first. So the x is 0. 1 plus 2 times -1/2. Is this true? Okay, so 0, is that equal to 1 times 2 times -1/2 will be negative, a positive and negative. And I know when I'm multiplying these two fractions, 2 goes into 2 once, so I've got 1 times 1 or 1 there. 0 equal to 1 minus 1, that's true, right? 0 equals 0, that's true. So this one is yes, it is a solution. So 0, -1/2 is a solution to this equation in 2 variables. Let's look at our last one here. I've got x is 2, y is -2. So where I see y, we're going to write -2 equals 2 times x, which is 2, minus 6. We're going to see, is that true? So -2 equals 4 minus 6. That's true, right? 4 minus 6 is -2. So this is another yes. So 2, -2 is a solution to the 2-variable equation y equals 2x minus 6. So our next page. In objective 4, we want to find the solutions of an equation in 2 variables. How do we find solutions, or how do we find ordered pairs are solutions of an equation in 2 variables? Okay. Now, as we saw in the last example or there were ordered pairs that worked for an equation and ordered pairs that didn't work for an equation. What we're going to see in this example right here is that there are lots of ordered pairs that could make this true. We just need to figure out what they are. For example, one of the ways to do that is to choose x values and then find the x value or the y value that makes this true. For example, if I know that I want x to be negative 2, if this was going to be true, y would have to be equal to, let's see, negative 2. I need negative 3 times negative 2 is 6 plus 7. Y would have to be equal to 13. So the ordered pair that would make this true would be negative 2 comma 13. I'm guaranteed that that's going to be a true ordered pair for this equation because I found the y value that would work. Okay, so we're making a set of ordered pairs. I can make any set of ordered pairs work for an equation if I choose one of the values and find the other value. I can choose another ordered pair that's going to work. This one's y equals negative 3 times negative 1 plus 7. Negative 3 times negative 1 is positive 3 plus 7 is 10. So if I use the ordered pair negative 1 comma 10, guaranteed that's going to work for this equation. Okay. Keep going. Y equals negative 3 times 0 plus 7. Well, that would be equal to 7. So we're guaranteed that the ordered pair with an x equal to 0 and a y equal to 7 will be true for this equation. Let's look at another one. Y equals negative 3 times 1 plus 7. Negative 3 times 1 is negative 3. Plus 7 is 4. So the ordered pair 1 comma 4 is true. And also, y equals negative 3 times 2 plus 7. Negative 3 times 2 is negative 6 plus 7 is 1. So the last ordered pair here, 2 comma 1, is true for this equation. As you can see, I could just keep picking different x values. I could do 3, 4, 5, or negative 3, negative 2, or 1/2, or I could pick any number for x, and I would be able to get a new ordered pair where I have the x and y values that make this work for this equation. Alright, so what we want to do next is use this information here to graph the equation. Okay, so on the next page we're going to be looking at the same equation right here, so let me go ahead and copy those ordered pairs down. Alright, I just copied them down. Now let's go ahead and graph each of those ordered pairs. The first one, negative 2, 13, is a little bit off the graph. I'll guess that it's about there. The next one, negative 1, 10, right here. 0, 7, right there. 1, 4, and 2, 1. Now we're going to connect these ordered pairs. Alright, let me connect up to this one as well. There we go. Connect those ordered pairs, you can see a line is forming. Okay, now this line right here is actually called the graph of this equation. I would connect the dots that I get from making illicit ordered pairs to get the actual graph of the equation. Now you can see that there are other ordered pairs down here that I hadn't gotten already, but these are also going to be solutions. So if I would maybe, for example, plug 5 in, if I choose 5 for x, then it would be y equals negative 3 times 5 plus 7. That's negative 15 plus 7 is negative 8. And let's check. 5, negative 8. Perfect. So you can see the ordered pairs that I didn't graph, or I didn't already find, show up on my graph as well. Okay, so the graph represents all possible ordered pairs for this equation.